This is a new series where I analyze code that you submit and then I take it apart and build it up again like some kind of Frankenstein, but using software design principles, and then hope it still works. I'm gonna take you step by step through the refactoring process and explain exactly why I made certain design choices. It's time for the Code Roast. In this episode, what? You think that was over the top? You're absolutely right. I'm not sure how often I'm gonna do these code roasts. In fact, that also depends on you. If you have an interesting code project you'd like me to review and refactor on the channel, join the Discord server and submit your project there. In this episode, I'm gonna work on a game called Yahtzee. Bless you. Thank you. Thank you to Macberg for submitting the code for this episode. I'll try to be nice. Yahtzee, I'm sure you know it, is a dice throwing game where you get points for certain combinations of dice. Now, I'm not part of the elite that has an actual Yahtzee score sheet. I have this cheap Dutch knockoff called Scoreboard. By the way, this video is not sponsored by the company that makes these because, well, that would be a bit ridiculous. It seems I'm not very good at this. Let's look at some code. So in the original version there are two files. There's the Yahtzee file and the test Yahtzee file. That's already a nice thing that there are unit tests in this example. If you look at the Yahtzee file, we have a couple of classes. So we have a die, we have a hand, which is a set of dice. And then I'm going to scroll down a bit. Then we have a class that contains the rules for Yahtzee. So there's a couple of them. And then we have a scoreboard, which contains the scores, and it also defines what the rules are. And then after that, we have a function, a main function that is actually the main progress, the main process of the game. So that's the existing example. Let's also look at the test. So this is the file containing the test. So it imports everything from the Yahtzee file. Then we have a couple of test cases for the hand, a couple of test cases for the rules. So each rule has one test case and then that's it. Basically, let me run these tests and you see. So 10 tests and they all pass.
When you run the game, this is what it looks like. Actually, this is already pretty nice. This is a full house, so I'm not gonna say no to that. I mean, that's 25 points. So you see there's also a problem that if I select number 10, it actually selects number 11. So that's a bug we're gonna have to fix. So now I have 0 points. Damn it. Okay, one more time. I'm gonna re-roll 1, 2, and 5. And now I'm gonna re-roll 1, 3, and 4. And I'm going to take the 3 4s. So now I'm actually going to select 4 because I think that's going to give me the 4s. Yes, okay, 12 points, nice. So I'm not going to finish the entire game now because that will take way too much time. So let's go back to the code.
So in terms of separation, it's nice that there are already a couple of classes that represent different concepts in the game. You have the die and the hand and the scoreboard and so on. So let's analyze this code now and see where there are some issues. So the first thing I noticed is that there are coupling issues in the code. Let's take a look at the rules and the scoreboard, for example. So you see that the rules, it defines here a set of rules. So each particular rule is stored at a particular index in the map. And when we go to the scoreboard, there is kind of a redefinition of the same thing, except then its names. So that means you need to make sure that the order here is the same as the order here, otherwise your game is going to break. Another thing is that this rules class actually violates the open-closed principle. At the moment, the way that it works is that each rule has its own function. So we have aces, twos, threes, etc., 4 of a kind, and so on and so on. So those are all the Yahtzee rules, and they're stored here in the map. Now I understand why you store them in the map, because otherwise you'd have to deal with lots and lots of if-else statements, which is really bad. But let's say we want to create an extended Yahtzee game which has special rules, then it means we're going to have to dive into the details of this rules class and extend it here. And because of the coupling issue, we also have to make sure that we're adding it here to the scoreboard. So that violates the open-closed principle. It would be better if we had a kind of strategy-like mechanism where we can define what the rules are and basically add them dynamically. So when I refactor the code, I'm going to do that, but in a slightly different way. Final thing in the rules class is that there is some code duplication here. For example, each of these 4s, 5s, 6s, 3s, they each compute the sum, but actually this code is almost the same. So probably we can also rewrite this a little bit to reduce some of that duplication. A third issue is more on the architectural level. If you take an architectural pattern like model view controller, for example, you want to split the model, the data, from the view, how it's represented, to the controller, to the logic of the application. Here that doesn't really happen. If you look at what the view is in this particular application, that's actually the console. We're reading data from the console and printing it out. And the problem is that printing things to the console basically happens everywhere. So we're printing things in the hand class. For example, if we're rolling the dice, or if we're re-rolling it, or if we're showing our hand. We're also reading stuff from the console input in the hand class. Same thing for the scoreboard. So in the scoreboard class, we're printing things here. We have several methods for printing out the scoreboard and so on. And then we're also printing things in the main function. So as a result, where we print things and where we read things from the console, that's a bit all over the place. And that's problematic because let's say you want to create an iOS app version of this, so then you don't have console. It means you have to change things everywhere in the code. You can't use the hand class or the scoreboard class if you're not building a console game. Another thing is that, and that's also related to the architecture, is that the data is also not in a single place. You have the rules that are defined in the rules class in this map, but you also have the rule names, which are defined in the scoreboard. And the scoreboard also has the points. And that architectural issue leads to the coupling that I mentioned in the beginning. So we need to separate that a little bit better. And finally, there's two things that we should improve in the test. So let's take a look at this hand test case. So this is testing that the number of sides per die is actually set correctly. So we create a hand with 5 dice that each have 18 sides. It's going to be a pretty weird die, but could be nice. And then basically here it checks that the number of sides equals 18. Now that's fine, but the problem is that this actually hides a bug. So if you look at the original die class, you see that indeed the number of sides is set here. But if you look at what happens when we roll the dice, we're actually always rolling a value between 1 and 6. So this bug is actually not caught by the test. And the reason that it's not caught is because this test is actually a kind of trivial test. We're only testing that an instance variable is set correctly, and we're not testing any behavior. And that's one thing that's really crucial with tests to get right, that you're not just setting data values, but that you're actually testing behavior. So that's one thing. The second thing in this test is that actually this is testing mainly the happy pass. So we're testing that aces is correctly computed. We're testing that 3 of a kind or 4 of a kind is correctly computed. But it's also important to test the not so happy flows. So we should also test that something that's not 4 of a kind is indeed identified as being not 4 of a kind. I'm going to add one example of such a test later on, but let's first look at some other parts of the code. So as a first step, let's take this die and hand classes and try to make them a little bit better. So what I'm going to do is I'm going to create a new file here where I'm going to put the die class inside. There we go, and we're going to need obviously the random generator here. So I'm also going to simplify the die class a little bit. For example, now there is a mechanism where a die, when you start, has not yet been rolled. And here you have to make sure that the die has a value, etc. So I'm going to simplify that because this is actually not used anywhere in the code, and just remove that part and just assume that when we create a die, it's going to have a value. And it's always going to have a value. And that just makes things a lot simpler. So the first thing I'm going to do here is to call the roll method. And then let's also solve this bug. So this should be self.sides. And for testing, I'm going to add an extra optional parameter here so that you can also supply the face that the die is on when you create it. So if you supply that face, we're going to assign it to the face instance variable. Otherwise, we'll roll the die. This, I'm going to remove it. We don't need it anymore. And now we don't have to have this check here. Basically, this is always going to return this. And I'm going to simplify this even more because I don't think we need this actually. So let's just do it like this. What I'm also going to do is add a setFace method. Mainly because this is easier later on if you want to do some unit tests. So that's my adapted die class. let's add a hand file as well. So I can remove this from the Yahtzee file, and then I'm going to take my hand class and put it in here. And hand is going to use the die class, so we need to import that. And actually, since Python 3, we don't need to put this anymore in our class definition. So I'm just going to remove that, and I'll do the same thing here. Just slight simplification. There you go. This we don't need either. And also let's slightly rewrite this. So now die expects also a face. So let's put that to none. So initially it just rolls to a random value, and X is not used, so we can actually use an underscore here to make it a bit cleaner. So that's our initialization method of the hand class. Now in the hand class we want to clean up a few things. So for example, here there is a printing message. We don't want it to print a message. We can put it later on in another place, but we want the hand to work separately from the console. So we don't want to print anything here. That also means that this reroll method here is actually something that shouldn't be in the hand class at all, because this is actually a part of the game process overall. So this should actually not be here, but in the Yahtzee class. So I'm going to remove this now, and I'm going to put it for now in the Yahtzee file, and I'll clean this up later. So I'm just going to put that here. That's not going to work obviously, but I'll change it later. So I want the hand class to be mainly responsible for anything related to what you want to do with the hand. So you want to roll dice, you want to re-roll a set of dice, etc. So let's create a few methods here that allow us to do those kind of things. So one thing that I'd like to have is a method that gives me the indices of all the dice in the hand. So if I have 5 dice, I want to have 1, 2, 3, 4, 5. And that's useful because we're going to need that to select how many dice we're going to re-roll later on. And this is actually really simple. It just returns a range. And the dice instance variable contains how many dice we have. So that's going to help us. Second thing I'd like to do is have a roll method where we can identify how many dice we want to roll. So here we have the throw method that just rolls everything. And we had before the reroll method that rolls a part of the dice. And that's actually what you see here. So here it's rolling those dice, but I like to create a method that does those two things in one. So I'm going to create a roll method. So you rename this, and then we can supply the dice that we want to roll. So I'm expecting dice to be a list. And we just need to make sure that every item in this list is within the allowed indices. So for any of those elements in dice, it's outside of the range, then we're going to raise an error. There we go. And then we're going to roll the dice. So I'm going to replace this with another for loop. And we're going to roll the dice at those indices. We need to subtract 1 because arrays start counting at 0, and this dice list is counting at 1 because that's the user input. So also the clear method is not used, so I'm just going to remove it. It's a nice application of the you ain't gonna need it principle. If you ain't gonna need it, don't implement it. Implement it when you need it. So then we have the get hand method. So in principle, the way this is set up is fine, but there's a slightly shorter way to do it. And this line basically replaces all of these lines. So that's a bit shorter. And let's see, for testing, I'd also like to have a method that allows me to directly set the faces of the die to a certain value. And when I write the unit test, this simplifies things a lot, because if you look at the test now, you know, this is kind of cumbersome to set the faces in this way. Another thing that would be nice if we add a few convenience methods to the hand class. So for example, often we have to count the number of occurrences of a particular die. For example, if we want to count the 1s or the 2s or the 0s or whatever. So let's add a method that does that. This gives us an array containing all the faces. And this has a built-in method called count that counts the number of occurrences of a value. So that's all we need to do. And let's also add a sum method that just returns the sum of all the dice in the hand. We could compute these things in other classes as well, but this just makes it a little bit more convenient. So then we have this showHand method that prints the die to the console, which is something I prefer not to do because I'd like to separate printing out things from the actual data like classes such as die or hand. So what I'm going to do, and actually die already has this string method, which is actually a better way to do it. So I'm going to add that to the hand. And then we're going to use that instead. And what we're going to do is create a list of strings that represents each dice information, similar to what is happening here, but then we're returning that as a string separated by new lines. And then create the strings here as a list. And now what we can do is simply call the print method on the hand, and then it's going to return this. And showHand is no longer needed. So what we've done now is separate printing out the information from both the die and the hand classes, which is in the end a bit cleaner. Now next step is to create the setup for the rules. So in the current code, rules is one class that has several functions, and I'd like to turn that into a strategy. So I'm going to add another file here. And in order to define the rules, I'm going to need the hand, because rules compute the number of points depending on the hand that you have. And then I'll also use an abstract class to define what a rule actually is. And what I'm going to change is that in the current version, there's a class that computes the number of points per rule. And then later on, we have a place where we define the name of the rule. So I'm going to put those two things together. So a rule is going to have an abstract method called name. And that's going to give us the name of each rule. And it's also going to have an abstract method points. And in order to compute the points, we need to know the hand. So since it's an abstract class, we don't provide the implementation of these things yet. So let's go back to the rules themselves. So I mentioned before that there was a little bit of duplication there. So what we can now actually do is create a subclass to cover some of that duplication for us. So for a number of Yahtzee rules, we're simply counting the points as the sum of the occurrences of a particular die in the hand. So we count the number of sixes, we count fives, etc. So let's create a class for that that already covers that for us. Then we can reuse that. Let's call it same value rule. And that's a subclass of rule. And we're going to add an initializer method to that. And we're giving that a value and the name. So we can create this in one go in just a few minutes. And then we provide the implementations for the name and the points method. The only thing we need to compute in the points method is simply count the die in the hand of a certain value. So we're using this count convenience method that I just added before. And multiplied by the value. So we can now create rules based on this class, for example, for sixes, and then the value is 6, and then it's going to count the total number of points as the sum of all the sixes. And we can do the same thing for aces, 2s, 3s, etc. So let's create another file, Yahtzee rules, where we're going to define all of these rules. And let's say we want to create a class to represent the aces rule. So that's a same value rule, and obviously we need to import that here. And we're going to give this class an initializer that sets the values to what we want to have. So the value is 1, because aces is 1, and we give it the name aces. And actually this self is not even needed. So then we end up with this. And I can create same classes for 2s, 3s, 4s, etc. Now obviously I already prepared this, so I can just simply paste them here. So now we have the same value rule implementations for each of these different types. So you can do the same thing for the other rules. Basically for each rule, we're going to define a class that determines what the name is and how we compute the points. So obviously I already did that, so let's copy that over here so I don't have to bore you with writing and copying over all these rules. So this is what that looks like. And there's one rule where I did something slightly different and I just want to show you quickly. And that's actually with the straight. So this is how straights are being computed in the original version. So basically it looks at the hand, and then for each thing it looks whether the following things are +1, +2, +3, and it's sorted, so that works. But there's a slightly shorter way to do it, and I'd just like to show you how I did it.
So here you have the class of Yahtzee rules. So let me scroll down. Here you have the small straight rule and the large straight rule. What I did is I made a class straight that helps me determine whether something is a straight by using this function. This expects a list of dice, and how I determine whether something is a straight is by looking at a specific property of consecutive number lists. If you have a list of consecutive numbers, so 1, 2, 3, 4 or 2, 3, 4, 5, you can actually compute a sum of those consecutive numbers using this formula. So this is a mathematical definition of how to compute the sum of a list of n consecutive numbers starting at 1. And this is a simple closed form solution to compute that. Now, if your consecutive list doesn't start with 1, but with a higher number, so you have 2, 3, 4, 5, 6, for example, then it's slightly more complicated, but it's still easy to compute with a single formula that's written here. So the first thing I do is check that the list doesn't have any duplicates, because if it has, then it's not a straight by default. So first I create a deduplicated list of numbers, and then I verify that the lengths are the same. If they're not the same, I'm returning false. Then I compute the consecutive sum, and then I verify that the actual sum is equal to the consecutive sum. So with the small straights, there's basically two options. Either the length of the list that I got is already 4. That means that I put away one die, and then I can just check whether that list is a straight. In that case, I return 30 points. If the length equals 5, then I just have to check that either the beginning part or the end part of the list is a straight. And then I'm also returning those 30 points. Large straight is even simpler. There I just call the isStraight function with the entire hand. And if that's a straight, I return 40 points.
So now let's move on to the scoreboard. I'm going to add another file. And I'm just going to copy the original scoreboard from the Yahtzee file. So that's this. There. And the scoreboard, we have to do a couple of things. We have to remove a lot of printing because that's part of the game process. And we also want to remove this responsibility of defining what the rules are so that we can use this scoreboard for other games as well. So again, object is not needed because it's Python 3. And we're going to make the scoreboard class really simple. There's basically two things, the rules and the points. And they're both arrays. And in order to use this scoreboard, we want to be able to register rules. So let's add a function for that. And we're going to provide it with a list of rules. And in order to append those rules to the rules array, we're going to use the extend method, which does that job for us. And when we do that, we also need to reset the points. So points are 0, and are just multiplied with the number of rules that there are. Let's add a few convenient methods, like counting the number of rules that we have. And also a method for getting a particular rule. So one thing that we probably want to do is that given some rule and a current hand, we want to be able to assign points. So let's add a method that does that. And that's kind of a replacement of this set scoreboard row value. The problem here is that this one expects a specific row, and that means it's pretty dependent on the specific structure of the list of rules. And what I want to do is I want to be able to provide a particular rule and a hand and let the scoreboard itself figure out how to do that. So first I'm going to find a row that this rule corresponds to. And if that row is not valid, so if there are already points that have been assigned, we're going to raise an exception. And that's actually this one. So you also see I'm moving here from printing the result and returning false to actually using the exception mechanism, which is a bit cleaner. Then let's compute the points. So there we can use the points method that each rule has. And let's assign that. And also return the number of points as a result. So that's assigning points. Let's add another convenience method to compute the total number of points. Because we're going to need that if we want to print that information later. Finally, so let me just remove this because we won't need this anymore. So now there are some methods that we have to think about what we're going to do with this. So there is here a method for showing the scoreboard roles. We have a method for showing the scoreboard points. And we have a method for selecting the scoring. So again, selecting scoring is something that's really more part of the game process and not so much of the scoreboard. So I'm going to remove that from the scoreboard and then move it to the Yahtzee file and paste it here. And we're going to clean this up later. So let me just save that for the moment. And then basically the only thing that I think we should do here is have a method that allows us to print out the scoreboard. And here there's actually two versions. So there's one version that just prints out the rows, and there's another version that prints out the rows and the points that you already have. So I'm going to combine those into a single method that can do both of those things depending on the parameter setting. And let's call that create points overview or something. And I'm also going to supply it the hand, so we can even indicate how many points you would get if you were to choose that row in the scoreboard. And default, that's none. So if you don't supply a hand, it won't show that information. So let's create an array of strings and add an element to that array for each rule in the scoreboard. And there's basically two cases. So if there is a hand and the current number of points is 0, and the points that are possible with that particular rule are also more than 0, it means that the rule is valid, then we can display the number of points. And here you see why it's nice that the rule contains all the data, because now we can simply write rule.name. And in this case, we're going to write down the number of points that's possible if you choose this rule. Let's add 3 stars. If not, we simply provide the name of the rules and the current number of points. I'm just going to copy this. Write that here, but make it a bit more simple. Oh, and I forgot to actually retrieve the number of points. There we go. And now we simply print out the number of points. And this, I'm just moving it over to the Yahtzee file, which is becoming a big mess now, but we'll clean it up in a minute. So now our scoreboard is also really clean. Oh, it's expecting a few things. That's much better. And we don't need to do everything anymore, so I'll just remove that. So that's our scoreboard. And now the Yahtzee file, we can concentrate here on creating the class that's actually responsible for the overall game process, printing out information to the screen, etc., etc. So there's a couple of things I can remove here, like this rules class, we don't need that anymore. So I'm just going to remove all these rules. There we go. We don't need this. And I'll probably also need to add all these imports. So what are we going to need? We're going to need a hand here and the scoreboard. And the Yahtzee rules. And let's just import everything. And then let's create a class where we're going to put in the methods that represent the main process that's part of the game. So let's call that class YahtzeeGame. It's going to have an initializer. And in the initializer, basically we're going to put the stuff that was in this main method here. So I'll copy this over. There. And then we begin by instantiating hand and the scoreboard just like in the original game, but we're just storing them as class instance variables. And these are default values, so I'm not going to put them here. So I'm creating the hand and the scoreboard. And now this is also the place where we're going to define what the rules of the game are. And for that we're going to call this register rules method. And now we simply create the instances of all the rules that we defined before. So now let's set up the overall process of the game. And for that I'm going to add a play method. And the main responsibility of the play method is to make sure to govern the overall process of playing the game. So the overall process is to keep going until the scoreboard is full. So that's the part that you see here. And then we show the number of points and quit the game. So I'm just going to copy this over for the moment and then refactor it later on. So just going to move that to the play method. And we need to change the logic here slightly. So we're actually going to make this very simple, and it's just going to be a for loop that's going to run the number of times that we have rules on the scoreboard. And that's where our convenient method for counting the number of rules comes in handy. So that replaces that while loop. And now this part, this is actually a turn in the game. So let's separate that out to another method. And here we need to do a little bit more work because we're also responsible for printing the things, and we remove that from the other classes. So we have this reroll method here. So let's go to that method definition. So that's actually this. So this is actually kind of what a turn is. So I'm just going to copy this over and I'm going to put that stuff here. There you go. And now let's see. So we start with rolls as 0. And let's say that initially we're rolling all dice. So I'm going to have a variable, selected dice, and that's uses the all dice convenient method from the hand class that I defined in the beginning. And then this check I'm not going to do here. I'm going to do that a bit later. So while true, and then I'll break out of the while loop at the appropriate places. So what do we need to do? Well, first we need to roll the dice. So I'm just going to remove that here because we don't need that anymore. So in a turn I'm going to roll the dice. So this is where I can print some information. And I'm going to use my generic roll method that takes a number of dice. In this case, it will be all the dice. So that's in this variable. And then we can change that later on. And because hand has an underscore underscore str method, I can actually simply print it here. Like so. And rolls, we keep track of how often we have rolled until now. And that means if we reach the maximum number of rolls, we're done now. There we go. And then optionally below, we're going to ask the user to reroll, and that's basically this whole part. So we want to let the user choose which dice to reroll. And let's add another method that does that for us. And basically that's going to be this part. So I'm just going to copy that over and create a new method that's going to contain this. And here we want to ask the user to enter the dice to reroll, and I'm going to put that in a while loop as well, so that if there is an error we can retry again and again until the user gets it right. So here we'll ask the user to input which dice to reroll. I'm not going to change this, but here basically what we need to do is return simply all the dice. And we can use the all dice convenient method for that. In the other case, we're parsing and splitting the reroll just like in the original game. And we just need to handle a few specific cases here. For example, this one. So if we didn't provide any reroll value or there's a 0 in there, then we assume that the player doesn't want to reroll any dice. So we return the empty list. If not, we return the list of desired rerolls. And these things we actually don't need here. And the continue is also not needed. So let's go back to the do turn method. So that should call the choose dice reroll. So here we're choosing which dice to reroll. If that's the empty list, we're done because the user doesn't want to reroll any dice. And now we need to do the last part, which is select the scoring and show the points. So the select scoring method now returns the rule. And let's create a select scoring method that does that job for us. And for that, I'm going to copy over this method. Just going to move it over here. Hand we don't need to pass because that's actually an instance variable. And here we basically need to refactor this code a little bit so that it works with the scoreboard directly. So the first thing we want to do is show the number of points. So we're going to make a method show scoreboard points. So we have these two actually. And let me just copy this one. This one we're going to use for two cases. Either we want to print out just the number of points, or we want to also show what possibilities there are. And we did add that to the scoreboard because here we have this create points overview that actually takes the hand as a parameter. And I see that I forgot something here, so I should just make this the right variable names and then return that as a result. Yeah. So let's call this method with optionally the hand. So we're going to pass that as a parameter. And then optionally we can leave it out and then it will only print the scoreboard without the potential points. So we're still going to print this out because that looks nice on the console. But then we're simply going to print the scoreboard create points overview result. And this stuff we don't need then actually. So that's for showing the scoreboard points. And we need the hand here because we're going to select the scoring. So we want to show the potential points to assign. And then we're going to let the player choose which scoring to use. And we're going to simplify this a bit because here you could leave the input empty to show the available roles. I'm just showing it always. So that kind of simplifies the way to do this. So again, a while loop, and we break out of the while loop when we got the correct values. And what I'm going to do is simply copy over these things and revise it a little bit so that it works with the new scoreboard system. So I'm not going to bore you with that part. I'm just going to remove these things and copy over what I already prepared. Because this video is starting to be pretty long. It's simply retrieving the rule of the scoreboard. Now here the rest is actually pretty straightforward. So now I can compute the number of points. And for that we need the rule that was selected and the hand. And then we can also print this. There we go. And finally we can call again show scoreboard point without passing the hand to show what the new scoreboard looks like. And that's basically it. So now these things I can remove. This I can remove. And this we can also simplify. So the only thing we need to do here is create the Yahtzee game and then start playing. This is actually not needed because this is already the end of the script. So I'm just going to remove this. Oh, small error. I still need to fix this, obviously. So this is just going to show the points. And then this we can also simplify because we already have a convenience method in the scoreboard to compute what the total number of points is. So I'm just going to remove all of this. There. Almost there. Yeah. So let's run this game again. It works really in the same way as before, except we've much better separated everything. Do you see this? I just got a large straight. So I want to keep that, obviously. And let's see, yeah, give it to me. Large straight. All right, great. So what happened in this new version? So first, responsibilities are much better distributed. We have the YahtzeeGame, which is responsible for all the printing and the overall game process and everything. We have the rules, which are here in separate classes. If we want to have more rules, we can add more rules. It's not a problem. The scoreboard is independent of the kind of rules that there are. And there are a couple of classes, like the rule abstract class, that defines what a rule looks like. And we avoided some code duplication by using subclasses. And then we have the very generic die class and hand class that allow us to manage a hand of dice. So the Yahtzee game itself, as you can see, is now responsible for defining what the rules are, which makes a lot more sense. So everything is in the same place, so that's much cleaner. And that means if you want to have a custom Yahtzee game, you simply add an extra rule here and then the rest of the software will still work without any issue.
As an example, let's add a custom Fibon-Yahtzee rule. I'm just going to copy over this class to define my new rule. So that's Fibon-Yahtzee. And also returning that as a name. And then in the points function, I'm going to compute whether the hand is a Fibon-Yahtzee. Okay, how many points is Fibon-Yahtzee? Well, let's say 100 points. Sounds good. I'm going to save that. So now I have my new rule. And now the only place where I need to change anything is in the Yahtzee file. And I simply add it here. So of course I need to import it. And then I add it to the scoreboard. There you go. That's the only thing you need to do now to register a custom rule, and all the rest of the game will simply work.
There's a couple of limitations to what I did. So I tried to separate the printing more from the data, which is what happened. But the game process, which you could kind of see as the controller, is still mixed up with printing. So that means that if you look at it from a model view controller point of view, that the view and the controller are actually still kind of mixed up. So I think it would actually be nice to split up this YahtzeeGame class even further and separate the printing of the game from the process of the game. But this video is already getting really long, so I don't want to spend any time on that. If I were to turn this into, let's say, a commercial version of the game, I would definitely work on that part as well. Second thing is I didn't write any test for the UI. I think having UI tests would also be really useful. These are a bit harder to write than the test you would do with the dice and the hand, but it's still possible to do it. I might cover that in another video. Actually, the tests are also now pretty simple because what you can do, let me show you just one example. So I could import the Yahtzee rules. And if I wanted to test the aces rule, I could simply do that here. And this is where the set faces method comes in handy. So we create an aces rule object and let it compute the points for the hand, and it should be equal to 5. So there's no longer a for loop needed, which makes writing these tests a bit shorter. And you can do this for all the different kinds of things. I'll do one more. Let's say we have the full house rule, so I can do something similar. So we have something like this. And I mentioned in the beginning that it's also good to test the not so happy flow, because this is the happy flow. So you should also test that something that's not a full house is also properly identified as such. So let's do something like this, for example, and then we expect this to be 0. And when you convert all these tests to the new format, so then this is basically what you're going to end up with. So you have your die test cases, your hand test cases, rules test cases, and optimally you'd also like to add user interface and scoreboard test cases here. All the code that I worked on in this episode is available in the Git repository. I put a link in the description. Thanks again to MacWork for supplying the code. I hope you enjoyed this refactoring session. It's been a long day. I think I'm gonna crack open the beer and chill out a little bit. Make sure to subscribe if you haven't done so you don't miss out on anything. Thanks for watching, take care, and see you in the next video.